All right, here we go with some parallel and perpendicular lines. So I tried to speed this up for you guys, so I'm going to read these first few definitions, and then I want you to pause this video and make sure you have these things written down. Remember, including the notes, that's a part of your daily assignment. So when you upload, I need to be seeing that you're doing these as well. So our goal today, instead of our topic, okay, our goal is that you can explain the difference between parallel and perpendicular lines. Okay, and then our definitions for the two parallel and perpendicular lines that you should know. Parallel lines never cross. You think of maybe a pair of railroad tracks like what they have written right here. And perpendicular lines cross at 90 degrees like your standard road intersection. So pause that and make sure you have those written down, and then we'll get going from there. So algebraically, how do we know that these two lines are parallel if we go back to parallel? So if we're going to apply that to what we've been doing this chapter, they have the same slope. Remember, our slope is m. Okay, so your two m's are equal. That's it for parallel lines. Really easy. What they typically have when we're doing these, when we start comparing them down the road, what's different with them is the b. Okay, they'll have the same slope. The m's will be the same, but their b will be different. So we'll get to that another day. But our perpendicular lines, how do we know that two lines are perpendicular? They have what we call opposite reciprocal. Big word there. Slopes. Opposite reciprocal slopes. Okay, and down here, as we get into our examples, because parallel lines, like we said, they're the same. So we jump right into examples. It says, what are negative reciprocals? Well, negative is really a bad word because as you'll see on like number 3, the answer ends up not being negative when I get there in a second. So really what we want is the opposite reciprocal. So in all of these cases, one will always be positive and one will be negative. Okay, so our first one here, you're just going to take the fraction and flip it. That's the reciprocal part. Reciprocals, if we think back to middle school, reciprocals are two things that multiply to get to 1. So that's the reciprocal part. But now we also need to add the opposite part. So one's positive and the other is negative. So we go to number 2. 2 over 1. The reciprocal of 2 over 1 is 1/2. You flip that fraction. And then since this one's positive, you make this one the opposite and make it negative. Well, like I alluded to on this one here, this one's already negative. So you flip it. And just take your reciprocal. And since the negative was here, this one's positive to get your opposite reciprocal. So these are all, again, examples of perpendicular lines. And the perpendicular 1 to 1 over 1 is negative 1 over 1. On to some examples for today. So what we have to do with these, you're going to get some practice with your slopes. So if we are given two ordered pairs, x1, y1, and x2, y2, remember, to calculate slope, you have to do y2 minus y1 over x2 minus x1. So you have to determine if these are parallel, perpendicular, or neither. So if you want to, you can go through and label these. I think it helps me, as long as I can read my x's and y's. And what I have to do, you're going to have to do 3 things here. So first of all, it says I have segment AB. So if I do AB, the first thing I'm going to do is figure out this slope. So I do AB, segment AB. I have my y's on top, 6 minus 3. My x is on bottom. Be careful here. 2 minus a negative 2 becomes positive 2. So I had 2 negatives there. 3/4. And I just stop there. Now I go to CD. Let me make this font a little smaller. See if this makes it better. There we go. So same thing here. And I like labeling. I'm not saying you have to. If you're on a test or quiz, you might want to decrease the chance of making a mistake. I have 3 minus 0 on top, y2 minus y1, and 3 minus a negative 1 becomes plus 1. So I also have 3/4. So you'll notice that they are the same. So I have line AB, 3/4 is my slope, line CD, my slope. When that happens, they are parallel. Jump over to number 2. And just for the sake of speed, I will just do 4 minus 2 on top. That's my y's. And 5 minus 0 on bottom. That gives me 2/5. And that was for AB. Sorry, I forgot that part. So for CD, line segment CD, I do 3 minus 8 and 3 minus 1. So I have negative 5 over 2. So if we compare these two fractions here, one is 2/5, one is 5/2. So that part's taken care of. They're reciprocals. And one is positive, my 2/5, and one is negative. That makes them perpendicular. Last one for this section here, we're going to go x1, y1, x2, y2. I'm just going to label these real quick. All right, so we're going to do AB. So that is 6 minus 8 on top. 2 minus a negative 1 becomes plus 1. So I have negative 2/3. CD, I have 3 minus 2 on top. And on bottom, I have 3 minus a negative 1 becomes plus 1. And I get 4. So what you notice here is I do have one that's negative and one that's positive. So we cover the opposite part, but 2/3 and 1/4 are not reciprocals. So we have neither in this case. Down here, given equations, I will do 9, 11, and 13 for you real quick. These are going to be quicker as long as you do not have to solve for to find out the slope. So you always have to have these in y equals mx plus b form. If it's not, do this first. So here, we're going to do 3 things again. This slope is 7. What is in front of your x? This slope here also 7. That makes them parallel. This one here, again, is already in y equals mx plus b form. This one has a slope of -1/3. This one has a slope of +1/3. That's neither. In order for them to be perpendicular, you would have needed to have 3/1 and -1/3, because then you would have your opposites and your reciprocals. We didn't have that, so we have nothing. And I'll do one more. This one right here, and this is going to pop up a couple times when I look at 12 and 14. When you do 12 and 14 on your homework, first thing you need to do is solve for y and show me your steps. Whenever I check for work, these would be the types of problems that I'm going to look at. So I just subtracted 5x. And now I divide everything by -1. So y equals 5x minus 4. So one of my slopes right here is really 5/1. This slope here is -1/5. Therefore, these two slopes are perpendicular. So again, I did this three things here on these. Find slope 1, find slope 2, and then decide if they're parallel, perpendicular, and or neither. 1 through 16 all is your assignment. And always, please, guys, show your work. That is all.